Okay, so the instructions for 27 say write an equation for the parabola in standard form. So they want it in vertex form because standard form is what we're used to calling vertex form. So we'll put standard / vertex form. So since we know we got to do that, when you see that, first of all, go write the form of the equation you need. It's this, isn't it? X and y equal a times x minus h squared plus k. Can y'all see that, or is my head in the way? Let me get over here. Okay. And this all we get is this graph. They want us. Then they say use a graphing utility to graph the equation and verify your results. So what you get is your equation. You're going to put in your graphing calculator and see that it matches this picture. This is basically how you're using your graphing calculator. Okay. Do you have enough to get started? What all are you missing here? What do you have and what are you missing? Do we have our vertex? Yeah, and that's what the HK is, right? So let's go put what we know in. Sometimes it's good to do a little bit at a time. X minus, my H is minus 1, right? And what's my K going to be? Remember, this is my HK up here, my vertex, right? So isn't that 4? So what we just filled in was the H and the K. Let's clean that up a little bit. Oops, got to put the square on it. X plus 1 squared plus 4. What all do I have to do to finish this equation? What's the piece that I'm missing? I'm supposed to have an X and a Y, aren't I? Is there something up there? If I had it, I'd have my whole equation.
Well, it could use a negative sign to...
Yeah, we can. You know what? Let's find it algebraically, because if we start putting negatives on stuff right now, we might mess up something we didn't intend to, okay? So we do know that when you're looking out in front of that x plus 1 squared, aren't you?
Mm-hmm.
We know there needs to be a negative and a number out there because there's an A in there. We don't know what the A is supposed to be, but we do know it's supposed to be a negative number. So how can we find it? We don't have it sitting up there in front of our face anywhere. Do we have anything that we could use in the equation, though? Anybody got any ideas?
You could set x and y to one of the points.
That's exactly what you do. You go, okay, I don't have the A, but what if I took something I do know, a point on the graph, and I plugged it in? If you look at what would happen if you do what Kate said, let's say, I'm going to pick 1, 0 just because it's a nice, easy number. Easier to plug in than -3 might be. So when y is 0, I'm picking this point, we have A, see, x is 1, so I'll plug that in. Could have picked the other point. This one just seemed better or easier. That would be A times 1 plus 1 is 2 squared, and 2 squared would be 4, wouldn't it? Plus 4. So 1 plus 1 squared is 2. 2 squared is 4. So what I really have here, I'm going to come over here under the left-hand column. It's like it's backwards, but what I have here is 0 equal 4A plus 4. Can I figure out what A is now? Do I have enough information to solve for A now? Okay, yeah, because I just move this stuff around, and I can solve for A just by plugging one point in, and we can get it. So let's subtract 4, -4 equal 4A. Divide both sides by 4. Oh, A is -1. Kate said it should be a negative number, right? You see how that'll fall out real nicely if we just let the algebra give it to us. So if I want that equation, all I got to go back now and say, okay, well here I had almost all of it. I was just missing this A. So if I plug that -1 in, I get y equal negative. I can put -1 or I can just put a negative. I'll put the dotted one for the invisible one. X plus 1 squared plus 4. And if I look in the calculator and I graph this, this should match the one in the book. In problem 30, they tell us basically what they want is I'm going to get rid of that. What they want is the standard form of the equation again, which we're kind of used to calling vertex form. And they say they're giving us a vertex and they're giving us a point. So for 30, the vertex is 4, 1. And the point is 6, negative 7. Hopefully I'm reading the right line. And they want it in that standard, what they call standard form, which is this. So anytime you see that they want something in a certain form, write that equation down because you know you're working from that. That's kind of your structure to work from. What's one thing we could put in right now? Vertex. That's what I would always start with. So y equal a, x minus 4 squared plus 1. And if you need to label that vertex HK just so you put the right thing in the right spot, that's always, labeling is always a good thing to do. Now I have a point here, and they must have given it to me for some reason. I'm going to label it XY, because if I do, now I can see what can I do next. Got too many things missing, so I must need to put something in to find one thing at a time. Yeah, plug them in. Your Y was negative 7. We don't know our A. That's what we're kind of hoping to find here. We have an X that goes with that negative 7 of 6 plus 1. Okay, so that's negative 7 equals A times, 2 squared plus 1? 2 squared is 4, so wouldn't that be 4A plus 1? And now you got a nice, easy little equation to solve to get your A. Anytime you have equations, I don't care what we're working on, and you go, I just got way too many things missing to figure this out, just start plugging in everything you can and try plugging in a point, because usually that's what you got to do. It's pretty much always, that's what you end up doing. So 4A is negative 8. What does A end up being? Negative 2, yeah. Okay, so now we can write the equation. I'll write it over here to the side in different colors so we can see it. Y equal negative 2, and when we plugged the vertex in, we had most of it. X minus 4 squared plus 1, and there's our answer right there. Okay, so 44, let's read the instructions. Use a graphing utility to graph the quadratic function, okay? Find the x-intercepts of the graph and compare them with the solutions of the corresponding quadratic equation when y equals 0. Okay, when they ask us to find the x-intercepts, those are the solutions. So it's almost like they're repeating themselves here. You're kind of going to put this in the graphing calculator and look at it, and you're supposed to look at the x-intercepts and see if you can figure out what they are from the graph. And then they want to compare them with the solutions of the quadratic equation when y equals 0. So when I see the word, they're basically want me to look at the graph for the x-intercepts, and then they're wanting me to solve it myself, is basically what they're asking me to do. And when you look at this, you may think it's going to be hard, but this is actually an easy problem if you recognize what to do. Does anybody see what to do here? How do I find solutions to problems, to quadratic problems, to problems with squares on it? What are my options? I've got some options here. To find solutions, which are my x-intercepts. See, they're assuming here that you haven't realized yet that solutions and x-intercepts are the same thing. So they're basically having you do it algebraically, then check the graph and go, oh, look, they're the same thing. That's kind of what, their thinking is behind these directions here. I could use the quadratic formula, but nobody likes that. What's the easiest thing to do if you can do it? Factor, right? We can factor. Other things we can do is maybe square root if we can figure out a way to do that, which means complete the square usually, and we don't want to do that if we don't have to. Can I factor this? I can. Because, remember, to find solutions, you set y equal to 0. That's because you're looking for the x-intercepts. That's why we set y equal to 0. Nobody ever told me that when I was in school. It's like, oh, well, duh. Because this factors, this part in parentheses, it's nice that they've put the 7/10 out front. They're trying to draw attention to the fact that sometimes you can take something out and factor what's inside. Because couldn't you factor that with like a 15 and a 3? Plus 15 minus 3 would be 12. And then I'd get my 15x here minus my 3x here would give me this 12x in the middle. Remember, we multiply to get the number on the end. And the two numbers that we multiply have to add up to the number in the middle. And so that would work, wouldn't it? So if I want to solve it, all I got to do is take those two factors and set them equal to 0. Because if two things multiply to 0, well, here we got three things multiplied to 0. But if I got three things multiplied to 0, I know this is not 0, is it? Can't be, it's 7/10. Something's got to be 0 in order to get 0 when you multiply, so it has to be one of those two things. So that's how we find our answers. Wouldn't this one be x is negative 15? When you subtract the 15 from both sides. And this would be x is 3. So now what they want you to do is get your graphing calculator out, type this equation in just the way they wrote it, and look and see if your x-intercepts aren't these two numbers. And if you do, they should be, unless we've done something wrong. You may have to change your window, though, because this negative 15 is going to be outside the window that your calculator gives you.